negative kelvins present types of reactions. So a single replacement reaction is one where you have two reactants. One is an element and one is a compound. So in this case we have zinc and HCl. And we are going to predict the products of this reaction. So using an activity series chart like this one, we can determine what the products of our reaction are going to be. And using the chart, we can see that zinc is higher than hydrogen. So we can see that zinc is higher than hydrogen, so it is going to replace it. If hydrogen was higher than zinc, this reaction would be classified as no reaction. But since zinc is higher than hydrogen, it is able to replace it, and our reaction yields CnCl plus H. And balanced, that equation is written like that. Now let's show this with a human model. Human model time!
The reactants are
zinc,
hydrogen,
chlorine.
reactants, go!
Hydrogen, I challenge you for your chlorine. No zinc. Dun, 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 dun.
The activity series tells me zinc is stronger than hydrogen.
She is mine.
Our next topic is double replacement reactions. An example of that is AgNO3 plus NaCl. In a double replacement reaction, the cation of the first reactant pairs with the anion of the second reactant, like this. And the cation of the second reactant pairs with the anion of the first reactant, like this. Using a solubility chart, we can determine what the precipitate is. In this case, NaNO3 is aqueous, so AgCl is our precipitate.
Human model time!
The reactants are
Silver nitrate.
sodium chloride. Reactants, go!
Boosh.
AgCl and NaNO3 are formed. A combustion reaction is a special type of reaction where a carbon-hydrogen compound, like methane, combines with oxygen. The products are always CO2, carbon dioxide, and H2O, or water. Combustion reactions also produce energy, often in the form of heat, or explosions. Human model time!
The reactants are
Oxygen. Methane.
reactants, go!
Boosh. Go.
Next, we have synthesis reactions. A synthesis reaction is when two elements or two smaller molecules combine to form a larger compound. An example of this is Na plus Cl2 combining to form NaCl. And of course we must balance this equation, adding a 2 in front of Na and a 2 in front of NaCl.
Human model time!
The reactants are
Sodium! Chlorine!
reactants go!
I have so many electrons! They're weighing me down! So many! So many electrons! I need an electron! Just one electron!
Last, we have decomposition reactions. A decomposition reaction is when a compound, like KCl, breaks down into smaller elements, or into elements and smaller compounds. So KCl breaks down into K and Cl2. And to balance that, we would put a 2 here and a 2 here. Human model time!
The reactants are
Potassium! Chlorine! Potassium chloride!
reactants go!
Oh, we are just the best of friends! I love you too! I love you! You are hugging me way too tight.
Well, your protons make your mass look big!
Oh, and this is ZnCl2 because of compound rules. And this is H2 because of Brinkelhoff. Do we need to explain that? Do we need to explain Brinkel?
Just jump!
Well, I've literally never jumped off swings before. I've jumped
You're in
off-
snow, nothing's gonna happen.
Are you kidding me? You can get hurt worse in snow.
Olivia is not good. JK, unrecord. That was amazing.